Hey everyone, welcome back. And in today's video, we're going to dive right into routing technologies. And if you ever wondered how data gets from one point to another in a network, or how routers decide the best path to take, this is the video for you. We're going to cover everything from static and dynamic routing to important routing protocols like BGP, EIGRP, and OSPF. Plus, we'll look at how NAT and PAT help with address translation and how protocols like FHRP provides network redundancy. Let's get into it. Now, just for our learning objectives, we're just going to make sure that you understand the difference between static and dynamic routing. And we're going to learn about common routing protocols like BGP, EIGRP, and OSPF, explore the process of route selection, examine concepts like address translation, NAT, PAT, and FHRP. And lastly, we're just going to understand the role of sub-interfaces and VIPs in routing, or VIPs in routing, okay? First, let's talk about static routing. This is the simplest form of routing, where routers are manually configured by a network administrator. Static routes don't change unless you are manually updating them. So they're great for small networks or for situations where you want to have total control over how data moves. Now, with this, static routing doesn't scale well for larger networks since you do have to manually configure and maintain every single route. Okay, so in static routing, the router doesn't need to process any dynamic updates, making it efficient, but it's not adaptable to changes as you go. Now, moving on to dynamic routing. Okay, so unlike static routing, dynamic routing allows routers to automatically learn and share routes with one another. This means that if there's a network change, like a link going down, the routers will automatically update the routing tables to reflect the new best path. Dynamic routing protocols such as BGP, EIGRP, or OSPF make this possible. And these protocols exchange routing information between routers and adjust the paths as the network changes, which makes dynamic routing perfect for more larger and complex networks. Let's start with one of the most important dynamic routing protocols, BGP, Border Gateway Protocol. Now, BGP is used to exchange routing information between autonomous systems, which are large networks that may span multiple organizations, right? Now, BGP is critical for routing on the internet, as it is responsible for determining the best path for data across different networks. Now, BGP selects the routes based on attributes like AS path and next hop, which makes it a highly flexible protocol for large network type of environments. Next up, let's talk about EIGRP, or Enhanced Interior Gateway Routing Protocol. This is a Cisco proprietary protocol that's designed to be efficient and to be fast at converging when it comes to changes in the network. Now, EIGRP uses metrics like bandwidth, delay, and reliability to calculate the best path for data to travel. It combines some of the best features for distant vectors and link state protocols. And this makes it a great choice for enterprise type networks. Now, let's talk about OSPF, or Open Shortest Path First. OSPF is a link state routing protocol that's widely used in large enterprise networks because it's scalable and fast convergence. Now, OSPF breaks the network into different areas to reduce the amount of routing information that each router has to process. And this helps keeps things efficient. It uses Darska's algorithm to make the shortest path, and the routing decision is based on cost which is that metric for OSPF. So how do routers select the best path when they have multiple options? There are a few factors that the routers consider. One is administrative distance. This tells the router how trustworthy a router is. The lower the number, the more reliable the route. Also, prefix length. Routers prefer the most specific route, which means the one with the longest prefix match. And then metric. Each protocol uses its own metric to calculate the best path. For example, OSPF uses cost, while EIGRP uses a combination of bandwidth and delay. Okay, now all these factors, they help routers choose the most efficient route for data to travel. All right, let's talk about network address translation, or NAT. NAT allows devices on a private network to communicate with the devices on the internet by translating their private IP address into a public IP address. A more advanced version of this is port address translation, PAT, also known as NAT overload. That's what we call it. Now, PAT allows multiple devices on a private network to share a single public IP address by using different ports. This is really helpful to conserve IP addresses, and it adds a layer of security by hiding internal network addresses. Another important concept in routing is first hop redundancy protocol, or FHRP. FHRP ensures that if one router goes down, another can take its place without interrupting network connectivities. Okay, now protocols like HSRP, which is Hot Standby Router Protocol, or VRRP, Virtual Router Redundancy Protocol, and even GLBP, Gateway Load Balancing Protocol. These help provide this type of redundancy, which ensures that there's no single point of failure in the network. Another concept closely related to redundancy is the use of virtual IPs, or VIPs. A VIP is a IP address that isn't tied to a specific device, but instead it's shared among multiple devices. Okay, this is often used in high availability systems and load balancing setups to ensure that even if one device fails, the VIP remains available to clients. Finally, let's discuss sub-interfaces. These allow you to use a single physical interface to handle traffic for multiple VLANs by creating logical interfaces on the router. This is especially useful for inter-VLAN routing, where devices in different VLANs need to communicate with each other. Each sub-interface is assigned its own IP address and VLAN tag, making it easy to manage multiple VLANs on a single physical connection. Before we wrap up, let's quickly review what we've covered. Static routing is manually configured, while dynamic routing uses protocols to automatically adapt to network changes. BGP, EIGRP, and OSPF are key dynamic routing protocols that play different roles in different types of networks. Route selection is based on factors like administrative distance, prefix length, and metric. NAT and PAT helps with IP address translation, allowing private networks to communicate with the internet. FHRP provides redundancy to ensure that there's no single point of failure, while VIPs and sub-interfaces improve efficiency and scalability. These are some of the most important concepts when it comes to routing in modern networks. And thanks for watching. I hope this lesson gave you a solid understanding of routing technologies and how they're used to manage and optimize network traffic. If you found this video helpful, please give it a thumbs up, subscribe, and leave a comment for any questions or feedback. Also, check out the description for more resources. Until next time, keep learning and I'll see you in the next video.